hello, Mr. Ryan, are you alright? Okay, so yesterday we talked about reducing a number to 0, yeah? Let's review this a little bit, yeah? We have a 10, and we want to reduce it to 0. So we have only two operations. The first one is to subtract 1 from it, and the other one is to divide it by 2, right? So we prefer the division, yeah? Because that will help us to bring down the number more quickly than subtract 1, am I right? Yeah? So 10, that will give me 5 divided by 2, and then 4, and then 2, and then 1, and then 0, okay? Okay, so how many steps? 1, 2, 3, 4, 5. 5 steps to 0, okay? So now today's problem is slightly different. Is that we start from any number 1. We start from 1, and we want to reach the number 10, or any number. We want to reach any number. At each operation, you are allowed to plus 1, okay? So this is opposite. Plus 1 or multiply 2, right? Right? So if you look at these two, this is exactly the same like yesterday, yeah? This is the opposite. But we are given one more constraint here, is that for the multiply 2, you can only do it, let's say, n number times, okay? Okay? Yeah? So let's say if we are allowed to multiply, let's say if we are allowed to multiply 1 time, so what's the minimum number of operations to make 1 to 10? Okay, so m equals 1. We are allowed to do this multiply 1 time. So what's the answer? Come on, anybody?
What? Yes, sir.
We are allowed to do this multiply 1 time. What's the minimum number of moves? If we start from 1, we want to go from 1 to 10. So what's the number? What's the minimum number of moves? Well, we can do this multiply 2 only 1 time. Yeah?
5.
5 times.
Yeah.
Okay. So what's your approach to do this? What's your approach? What's your approach?
It's
Sorry?
to get to the n divided by 2.
N divided by 2. So
if we can do it, I will.
we are multiplying, so you're talking about division. So you are talking about reverse, yeah?
Yeah, so you start with divide.
You start with n, yeah? Then we can.
And then you start with dividing because you start with the biggest number and
Yeah.
you will move more quickly.
That's right, yeah. Okay, so we can make this problem the opposite. We think inversely, yeah? Inversely. We think the opposite way, okay? This is the same. So we have multiplied 2, right? So if we just start with number n instead of starting number 1, so we eventually make this problem like yesterday. We have 2 operations, -1 and divided by 2. But the only difference is that for the division we have n number. You can do this at most n number of times. So but as you said, at the beginning, if we can do this division, we prefer to do this division. Why is that? Because look, 1,000, if we do the division, now become 500, and then we reduce the number by 500, yeah? But if you do it from 10 to 5, only reduce to 5 times. You only reduce the 5, yeah?
Yeah.
So if we do it early, we can bring down the numbers quickly, right? So we prefer that, so we can do this quickly, right? And with this number of times. So the strategy is quickly, is very obvious that if we can do this division, we'll do the division, right? So when is the time we can do this division? When the number is even and we still have n number of times of division to do. N is bigger than 0. Otherwise, we can just subtract 1 until we get to 1. Okay. Okay, let's quickly write it. We can write this using 2 different approaches. One is let's do it in recursion. Okay. Let's say f function. We are now at number n, and we have n number of times of division. Okay. Yeah. What did Daddy just say? What's n?
We
What's
have
n?
n number times of division.
N is the number, and m is the number of division. Okay. Now look. if n equal 1, then we just done, yeah, return 0, yeah. If the n is 0, it's 1, we are done, yeah. We already at destination, okay. Now look. Now what's next? Look, if what? If m is bigger than 0, right? Look, if m is bigger than 0, we have m. We still have the divisions to do. We can apply, and also now current number is a even number, right? Yeah. Look, if we have enough division to do, and then we are now n is even number. Alright? Yeah. So now return what? Return what? Return what? What's return here? Come on. Can you do this using the f function? Look. So if I'm saying, okay, so I have one more, I can do this one more division. So then I can say I apply 1 plus f n divided by 2 and m minus 1, right? Look, what does this mean? Yeah, this we divided that by 2, so this is the new number. We have used one division. Now, okay, so we have used 1, so we have applied one more operation, so that's 1 here. Alright? Okay. Okay, now so what's next? So if the and at this point then m is 0, right? And okay, then we have to say if what? If m is 0. Okay, so if m 0, what happened? So we can't do the division anymore. So what's the answer? We can't do the division anymore. So what's the answer? What's the number of moves to bring n to 1? So we have a number n, and now we want to bring it down to 1. What's the number? We can't do division. So what's the number of moves?
N minus 1.
We're done. That's good. Return n minus 1. Yeah. Yeah. Easy. Yeah. Okay. Now if m.
Here.
Okay. So what's missing here? What's missing here?
Here.
What's missing here? Come on. Okay, so now we need to do what? If n is odd number. Okay, so now here n is odd number, right? If n is odd number, then what happened?
We minus the 1, thank you very much.
Then we look here we just do this 1 plus f n minus 1 and then m, right? Okay. Yeah. Look. Okay, can I repeat this? If the number is 1. If number is 1, we reach the destination, okay? Can I have this, please?
No, thank you.
Okay. Okay, this is good for me, okay? Look, if n is 1, return 0, okay?
Yeah.
If m is bigger than 1, we have n divisions to do, and then this is even number. Then return 1 plus this. Look, we have divided by 2, so this is the new number, new target, and minus 1, which is the division. Well, less than 1, yeah, because we have used one division. Right? If m is 0, then we have so what does it mean? We have no more division. So the only way we can bring down n to 1 is by subtraction, yeah. So that's n minus 1, as you said. Otherwise we're not sure. Then at this case here, what's here? It could be what? It could be m bigger than 0, or what? Or n is even number. N is odd number. Okay. So here it will be one of these, right? If n is bigger than 0, then I need to do this. But n is odd, I also can do this. But in both cases, I need to plus 1, and here is the subtraction. Okay?
Yeah.
Yeah. Make sense? Okay. So we can do this iteratively. Okay. If we can do this iteratively. How can we do this iteratively? So look, we can just do this. Define, let's say fn, right? So now look, we have the answer. Answer equals 0. So while n is bigger than 1, right? N. Okay, so there are n here, okay? M is bigger than 0, right? Right? So we can do this. Look. Do what? If n is even number. If n is an even number, so what happens? If n is even number, if n is odd number, we can only subtract 1. So n minus equals 1, and the answer needs to plus equal 1, right? Else, if n is odd number, so we prefer the division. So what? N divided by equal 2 and answer plus equal 1, okay? Look, both cases answer plus equals 1, so let's move this a little bit to the, to outside so we can, to make it clear, yeah? Look, if n minus, look, this is division, and we have used one division, so this here we need to minus n minus equals 1, right? Yeah? Okay, so now at n, what should we return? Return what? Okay, so if, look here, y n is bigger than 1 and we have division, and then outside, what's outside? If the loop terminates here, what's the outside? If outside here, what's the condition? What's the opposite of this? So why this condition is true, we do this. And if I'm outside, what happened? So
We do the opposite.
so what's this? If n is bigger than 1, so what happened here?
If n is smaller than 1,
It could be 1, right? N is equal to 1. Or, look, so the opposite is that n equals 1 or m is equal to 0, right? Yeah? If n equals 1, then we are done, right?
yeah.
But if m is 0, it means we have no division at all. So we can, how do we bring down the numbers from n to 1? You just say n what? If we n equals 0, what's the, how many steps to bring n to 1?
0.
No. N could be, look, the opposite of this is n is 1 or, remember or, yeah? Or m is 0, right? When m is 0, n may not be 1, right? So then how do we bring the n to 1?
n minus 1.
N minus 1, yeah. Yeah? So n minus 1, but remember we have an answer here. We have used answer here, so plus answer, right? Yeah? Does it make sense here? Does it make sense here? Which one do you think is better? Which one do you think is better? Look, this one, yeah? N divided by 2, you can also write it as n shift equals 1, okay? These two are the same when n is even number, okay? When n is even number, these two are equivalent, okay? These two are equivalent. Okay, so does it make sense here, this one? Okay, so what have you learned today so far?
We learned about it's called.
So, sorry, I
don't
mean,
know what is it called.
Minimum moves to reach targets.
Yeah, minimum moves.
Okay, so what's the approach here? What's the approach here? We are trying to prioritize which operation?
Plus 1 times.
2. Plus 1 times 2. I know we think it inversely, yeah? Because
If we have the limited
yeah.
range of times 2.
Yeah, because we have a number, we have a restricted number times to do this multiply. Yeah? If we think it reversely, if we inverse the problem, and the operation will be subtraction and division, right? And we prefer the division. We want to do this division as soon as we can, right? Because it will help bring down the numbers quicker. Am I right? Okay. So look, this is n. This is current number. Let me repeat again. This n is the number. N is the number of division we can do. When n is the 1, then we return 0. Yeah. Obviously we are at target. When when we have division and then this currently n is the even number, then we can do the division. Yeah. N divided by 2, and we have one less division here. 1 plus. If n, look. If n is 0, means that we can't do the division anymore. So we need the n minus 1 to bring down the n to 1, right? Otherwise, here what's the case? If m is bigger than 0, or n is odd number, then in both cases we need to subtract 1, right? And then we call in the recursion to handle a smaller problem, which is n minus 1 m, right? Yeah? N minus 1 m. Okay. And here we repeated it, yeah? Answer is the number of steps we've taken so far. when n is bigger than 1 and we have more, we can still do this division. When n is an odd number, we subtract 1 because this is the only way to bring down the number when n is an odd number. Otherwise, when we have still division to do, then we can do this division and we need to remember to do what? To subtract the division, okay? And then answer plus equal 1 because it applies to both branches. And when the loop breaks, so we still need to bring the number from n because n might not be 1, right? Yeah. So n minus 1 plus answer. Okay. That's it for today. What's the time complexity, by the way? What's the time complexity? Look, we have a division to bring down the number. If we have a division. Okay, so the best case is what? If n is a number to the power, yeah, like 128. So you always divide by 2, right? 128, 64, 32, 16, 8, 4, 2, 1, right? Log n. Yeah? Okay. That's it for today. Bye bye.
Bye.
Bye bye.